This video is for lesson 21-2 about 30 degree, 60 degree, 90 degree triangles, which is another special right triangle. Learning goals are to find the relationships among the side lengths in this kind of triangle and to apply those relationships to solve problems. For note taking, let's take a similar track to what we did yesterday and start with an example of this kind of triangle. So I'm going to draw a triangle. It's going to be a right triangle, and it's a certain type of right triangle where there is a 90-degree angle, a 30-degree angle, and a 60-degree angle. If we were to take a ruler and measure the side lengths of a triangle with this shape, we might get measures like this. Let's say that the shortest leg is 5 units long. The hypotenuse will be 10 on a ruler, and this other leg will end up being 5 times the square root of 3 units long. This suggests relationships among these three legs. For example, notice that the hypotenuse 10 is twice the short leg 5. Notice that the longer of the legs, the 5 square root of 3, is the same thing as the short leg multiplied by the square root of 3. And those are our special relationships for this shaped triangle. Let me draw one of these triangles again. It's going to be the same shape as that first one I drew. And on a protractor, let's say that that is exactly 30 degrees and that this angle is exactly 60 degrees, so that this is called a 30, 60, 90 triangle. Now, instead of writing numbers on the sides, let's use some variables. Let's say that I put S on this one, and this S is representing short leg. Let's say that I write L on this side, and that L is going to represent long leg. And then here, let's put H to mean hypotenuse. So now we can answer these questions over here. Write a rule for finding the longer leg. So the rule might look like this. The long leg equals the short leg times the square root of 3. Number 7, write a rule for finding the hypotenuse. It would look like this. Hypotenuse equals 2 times the short leg. We could rearrange these formulas if we needed to. For example, if we needed to find the short leg and we knew the long leg, we could take the long leg divided by the square root of 3. Over here, if we needed to find the short leg and we knew the hypotenuse, we could take the hypotenuse divided by 2. So here are some formulas that we can use with 30, 60, 90 degree triangles. It's really just 2 formulas, but I rearranged them to show what they look like in reverse. I'll pause the video to make sure you have these down in your notes. Let's move ahead to the check your understanding questions and work on number 10. In a 30, 60, 90 degree triangle, the length of the shorter leg is 6. So we were using the letter S to represent that in the formula, so we're saying that S is 6. Question A, what is the length of the longer leg? So the formula we need is L equals S times the square root of 3. And make our substitution for S, and we have the answer. Now question B, what's the length of the hypotenuse? The formula we need is H equals 2 times S. Make the substitution for S, and we find out the hypotenuse is 12 inches. Now number 11, in a 30, 60, 90 degree triangle, the hypotenuse is 10. So we're given that H is 10. Question A, what's the length of the shorter leg? Remember that we had a formula that looked like this. The hypotenuse is equal to 2 times the short leg. And we had rearranged that to say that the short leg is the hypotenuse divided by 2. So let's substitute 10 for H, and we find out the answer is 5 centimeters. Now question B, what's the length of the long leg? So we want a formula that had the letter L in it, which meant long leg. It was L equals the short leg times the square root of 3. What's the short leg? We just figured out it was 5. So put in the 5, and we have the answer. So in this lesson, we wrote some formulas that we can use for 30, 60, 90-degree triangles. These kind of triangles have a short leg, a longer leg, and a hypotenuse.